So in this section, we're going to apply our knowledge with more complex problems. So as I mentioned there, now you have all the tools you need for trigonometry. You know how to write a trigonometric ratio. You know how to solve for an angle of a triangle. You also know how to solve for a side length of the triangle. With these tools, you can solve any complex right triangle question, even if we combine multiple triangles together. So let's take a look here. It says exercise, solve for the indicated angle theta, round to 1 decimal place. So this looks complicated at first, but what we're going to do is we're going to work through it slowly so that we can eventually get that particular angle. Now, when you see these types of questions, you're trying to remember all of the information that you know. So what you know here is you want to find this angle. In the previous questions, in order to find the angle, most of the time, we had the other two angles, we added them and subtracted them from 180. So from that logic, it will be helpful to find this particular angle. We also know that when you have a straight line like this, all the angles that make up that straight line, so this angle here, this angle here, and this angle here, should also equal 180 degrees. That's something you learned in grade 9. So it would be helpful to have this angle as well. So what we can then determine is if we had this angle, we can figure out this angle, and if we had these two angles, we can figure out this angle. So what we want to do is find a way to figure out this particular angle. We see that some side lengths are given, so we think back to our tool. Can we use Pythagorean theorem? No, that's for side lengths. Can we use the angles rule? No, we have too many missing angles. We know we have to go with a primary trig ratio. So let's keep this as our angle of interest. If that's our angle of interest, we know that this is our hypotenuse, because it's opposite h. This side, which we'll call g, lowercase g, because it's opposite to this side, we know that's our adjacent. And this side is our opposite, and we can call that lowercase f. So in this particular question, we were given the hypotenuse as well as the opposite. If we think back to so katoa, that's just so. So sine, the angle of interest, let's call that f. All of these are technically f, so I'm going to call this f1, just to indicate that we're talking about this angle and not this angle f or this angle f, because that vertex is called f. Okay, so we'll call this f1. So the sine f1 is equal to opposite over hypotenuse, so 12.3 over 17.9. To solve for an angle, remember, if I'm trying to solve for an angle, the only way I can separate the sine out is by doing an inverse trig function. So I'm going to use the inverse and type in the ratio. So that gets me about 43.40499,402. It's an angle, so I know that's in degrees. And they wanted me to round to 1 decimal place, so I'm going to say f1 is 43.4 degrees. Now I have this, which is 43.4 degrees. I'm going to call this angle here f2. Because this is a straight line, I know all three of these angles will add up to 180. So here I have angle f1 plus angle f2, and I'm actually going to call this f3 then. So angle f3. So angle f1 plus angle f2 plus angle f3 should add up to 180 degrees. So that's 43.4 plus angle f2, which is what I want to solve for, plus 110.0 degrees is 180 degrees. I keep going. 43.4 plus 110 is 153.4 degrees plus f2, which is equal to 180 degrees. To isolate for f2, I subtract 180 by 153.4 degrees, which gives me 26.6 degrees. So I'm just making sure it's 26.6 degrees. So now I've solved for this as well, but the goal was to solve for the theta. I have this angle, I have this angle. I know all three of these angles should add up to 180. So let me write that down. Angle D, which is my angle of interest, plus angle E, plus angle F2 should add up to 180, and they add up to 180 because they're the three angles of the triangle. So angle D, I'm calling that theta, so I'm just going to replace that, plus angle E, I see that it's a 90-degree angle, plus angle F2, which is 26.6 degrees, equals 180. So simplifying this, 90 plus 26.6 is 116.6 degrees, equals 180 degrees. And to solve for theta, it's 180 minus 116.6, and that just gives me 63.4 degrees. Let me just make sure. So 9, 179, 180. Yeah, so theta is equal to 63.4 degrees. So again, we rarely use trig ratios here. We only had to use it once. We use more so, whoops, that's my calculator. We use more so our knowledge of the angles of a triangle to solve this question. So once again, there's a bunch of tools that you can use at your disposal. You just have to know which ones to use, and that comes with practice. The last example here is solve BD. So we want to solve this entire length round to one decimal place. So just taking a look here, I see two right angle triangles, one here and one here. I also see BD is the same thing as BC plus CD. So I'm going to write that off to the side first. BD is equal to BC plus CD. Why? Because the line segment that represents BD, I'm trying to find its side length, is going to equal this plus this, which is what I just wrote down. Whatever the side length here is, plus whatever the side length here is, will give me this total side length. So I know that as a fact. I have two right angle triangles. Sometimes it helps to just break them down into individual triangles. So let me redraw triangle one. So triangle one here is this left triangle. So if I redraw it, I have B, A, and C. I know B is 56 degrees. I know this side length is 150 centimeters. And that's all I know about that particular triangle. And if I take a look at triangle 2 here, again, I can break it down. So I have 70 degrees here. This is still A, C, and D. And this is 347 centimeters. Okay, so I have these two triangles. Why did I break it down? Because of pretty much this. If I find BC, which is this side length here, and if I can find CD, which is this or this side length here, I can add them together to get BD. So let's take a look here. I'm not trying to solve for any of the angles, so that angle rule of 180 might or might not come in handy. In order to use Pythagorean, I always need two side lengths. I only have one here and one here, so I can't use Pythagorean. I'm going to use my trig ratios. So I said I want to find this side. To name the side, it's the opposite of A. It will be A. So I want to find a side length. I'm given another side length and an angle. I can make a trig ratio here. Before I do want to label my adjacent, hypotenuse, and opposite. I've been given this angle. Let's use that as my angle of interest. If this is my angle of interest, this is my hypotenuse. This down here is my adjacent, and this here is my opposite. So in this question, I'm given the hypotenuse. I want to solve for the adjacent. Okay, so I have adjacent and hypotenuse. Thinking about SOHCAHTOA, that's essentially ka, or cosine. So the cosine of my angle of interest, which is 56, is equal to adjacent, lowercase a, over hypotenuse, which is 150. Here's a situation where I'm solving for a side length, so I need to create two fractions, one on either side, and do cross multiplication. So 1 times a is just a. 150 times cos 56 is 150 cos 56. I've isolated for a already, so all I have to do is I have to type this into my calculator. So 150 cos 56, which equals about 83.8789. The instruction said to round to one decimal place, so a is approximately 1 decimal place, 83.9. Okay, so that's essentially what I have. So now I know that A, which represents BC here, is 83.9 units long. I'm going to do the same thing here because I still need to find CD. So again, they gave me this angle. Let's treat that as my angle of interest. So here is my angle of interest. So this, again, being opposite of the 90 degrees, is my hypotenuse. This is my adjacent, and this is my opposite. I want to solve for this side length here, which is called lowercase a. So in this question, I'm just getting my colors out. In this question, I've given my hypotenuse, and I want to solve for the opposite. So SOH, I'm going to use sine in this case. So sine the angle of interest, which was 70, is equal to opposite A over hypotenuse 347. Again, I'm going to create fractions in order to solve for the side length. Then I'm going to do cross multiplication. So 1 times A is A, and 347 times sine 40 is 347, sine 70 is 347 sine 70. Again, I've isolated for my A here, so all I have to do is plug it into my calculator. So 347 sine 70 is 326.07333, and I wanted, again, just one decimal place, so 326.1. Now, I know my A here is 326.1, which means this is 326.1. I initially wanted to find BD, and I said that's the same thing as BC plus CD. Now I have BC, which is 83.9. I have CD, which is 326.1. And so when I add them, I have 83.9 plus 326.1. It gives me 410. They still wanted one decimal place, so I'm just going to do 410.0. And we can include units because all of these side lengths were in centimeters. So every side length that we calculated was also in centimeters. So 410.0 centimeters. So for homework, you're going to do handout C and D and hand it in on the Google Classroom. Thank you.